Well, most commercial airplanes don't fly at 1,500 feet in the middle of a glacier.
And that's just the first of many things that separates this from other airplanes. Hello, I'm Michael Starobin aboard NASA's P-3B Orion, and if you want to understand how IceBridge operates in northern latitudes, you have to understand this airplane.
P-3 is different from other planes. It's a large 4-engine turboprop, so we've got 75% of the wing covered with airflow. It gives us the ability to get down close to the glaciers, fly through them, and if we have to climb out in a hurry, we have that airlift capability because of those turboprops.
Built in the 1960s, the P-3 originally took flight during the Cold War. But no dinosaur this plane, NASA's high-tech workhorse now pulls for science. Even its subdetection housing now holds a scientific magnetometer. Upgraded with 21st century special modifications, it's less a Cold War relic and more like the space agency's Millennium Falcon. It's got it where it counts, but travel by P-3B isn't like flying commercial.
It's fast, it's got a lot of power, and it's very tough. So we can take a beating out here with some turbulence coming off the ice sheet, sometimes and down in the glaciers. And this is by far the best plane for this mission. You actually wouldn't notice that this is 50 years old. It's actually it's got a future air navigation system, avionics suite in it, which a lot of airlines don't have yet. We've got synthetic vision, TAWS, data link, really a lot of stuff that even the newest Navy P-3s don't have.
Even with high-tech avionics and a Top Gun crew, IceBridge flies low, and that keeps eyes on the flight deck wide open.
I mean, when you're at altitude, you have more time to react to a malfunction. If I'm at 1,500 feet in a mountain environment and I lose an engine or something catastrophic like that, the reaction time's a lot less.
It's monstrously loud. Passengers must wear earplugs, and noise-canceling earphones are strongly advised. But what it lacks in comfort, it makes up for in capability. For IceBridge, the P-3 is all about mapping, above the ice and below. To do that, it carries a symphony of sensors, and the best players to operate them in concert. NASA's Michael Studinger is their conductor.
Here on the P-3, a lot of different science instruments. In total, we fly 10 different instruments on this aircraft. We have several operators on the aircraft. In the morning, it's minus 15 degrees Fahrenheit outside. The airplane is very cold, the engines are very cold. But the tremendous advantage we have from flying 10 different science instruments on one single aircraft is we are collecting a very diverse set of science data at the same time over the same spot on the ice sheet in Greenland, and that has a tremendous scientific value in kind of helping to understand what is happening to the Greenland ice sheet and how it is responding to changes in atmospheric temperatures, ocean temperatures, and precipitation.
To learn more about NASA's Operation IceBridge and the P-3B on which it flies, visit us on the web.